Miss Madison? Oh, I heard about him. He's geometry, right?
Yes, he's geometry. Who's James's mom? We had her for algebra.
Oh my god.
Oh, I did not have a cute for algebra.
Like everybody's in love with Katie's dad. Katie's dad, Mr. Cohen.
Everyone loves him.
Yeah. Like I literally have a one student, Ethan Miser, is like, man, can I have your dad's phone number? And went up to Katie. It was like Katie's like,
He was really nice, but I don't know if he was the greatest teacher.
oh really? I don't know. That's what I heard. He's,
Oh, I'm not saying anything. Don't look at me right now. I'm leaving you behind. I'm leaving you behind right now.
You can't lie.
Goodbye. I'm not weighing in on this one.
Bro, our reading log, you don't even remember.
Bro, I lied about every single one of those reading logs. I was like, I read like 1,000 pages of Harry
You
Potter.
remember the thing where like we had different events we could do and you
Okay.
get no.
Oh my god, in the universe.
Universe.
Oh my god. Leave my ass alone. Like, I'm just trying to sit there.
okay, so if I want to take a derivative,
Reading log.
if I want to take a derivative of the constant c, what do you think it's going to be? If I take a derivative of a constant, what do you think it's going to be?
It's gonna be
Yeah.
Okay, so what if I say y equal to 2? What does that look like? Okay, so what do you think slope of that line is?
0.
Good. So it doesn't matter is y equal to 2 or 3 or 4 or 5? No, right? So slope of a horizontal line, let's just say c, let's say y equal to 2, let's just say here. We have y equal to 2. And what's my slope? Well, slope is 0. And you have to understand visually. So derivative of any number, y equal to 3, y equal to 4, doesn't matter. It's always 0. Super easy, right? This is called constant rule. So derivative of constant is always equal to 0. Now we're going to talk about this is a very, very powerful rule. It's called power rule. And if I have d to the dx of x to the n, d to the dx means I'm taking derivative. This is the action of taking derivative of x to the n, respect to x. So then the thing is, you take this n and they place in the front and just do nx. And the n is going to be n minus 1. And that's a power rule.
You literally just lost. Where did you put the n?
I take the n, place it in the front, and then subtract the power by 1.
Go back to C. If you C to the first round, you go C to then it'd be n minus 1. Isn't
C is
that equal 1?
C does we're not talking about C. C is a constant, so derivative of constant just automatically 0
Yeah,
because of
imagine
horizontal
it's
line.
like a number like number 5, so then it's 5 to the 1 power. So even if you are using the power rule, then you bring that 1 to the front. So and then it would be 1 minus 1, so it would be 5 to the 0 power, which would be. Oh wait.
Yeah, that'd be 1.
Never mind. Then I don't know, Mr. Yang.
Just derivative of the constant is always 0. Okay, so now here's one thing I will tell you. This x to the n is on the numerator. Is on the numerator. And we're gonna talk about if it's on denominator, you cannot do this rule. So it's on numerator. So x to the n over 1. That's technically it's on the numerator. Make sure. And if it's not on the numerator, you have to make it to become numerator before you take a power rule. So let's practice take a derivative of x to the 4th. What do you think derivative of x4 is going to be?
4.
Oh my god, you guys are so smart. Such a genius.
Honestly, I kind of think I got
Right.
that really fast.
Yeah, I was actually enjoying maths. I was doing how much doing like for once.
Square root of x.
See, why do
One
we
half
have this
x
weird?
to the negative one half.
Yep, we just talked about that rule, right? Which rule? A to the m over n equal to n roots of a to the m. This is called definition radicals. And before I take a derivative, I can change to the power. So it'd be 1/2. And then it's going to be 1/2 x to the negative 1/2.
Don't you get like a million times?
Okay, so but 1/2 x to the negative 1/2. And that's it. Is that hard? No. Okay, so how about d to the dx of this?
It's on a numerator.
Now on the numerator, good. You had to make it to numerator.
So when you make it negative,
Ah,
Oh, yeah.
X to the
Really?
negative
Yeah.
Really?
negative.
Yep.
Oh, I'm assuming.
All right.
I think that was right.
oh,
It'd be.
I think so.
What do you mean? Like,
so
Why
it'll
you
be
gotta say it like that?
it'll be x.
Yes or no?
If we make x to negative 3/2,
yeah. Right?
so it'll be negative 3/2
Yeah.
x, and then
Minus 5/2.
Minus.
X to the negative 3/2.
Yeah, minus 5.
Yeah.
No.
This one's gonna be x to which power? Negative 3/2, right?
Yeah. So then that'll be
Minus.
What
then
do you
negative
mean?
5/2 x.
Yeah, which is minus.
You're right.
Yeah,
I-
yeah,
Okay, also remember, also remember this can change into 1/2 square root x as well, because you can move it down and put in radical. That's how you evaluate it, because it'll be easier to evaluate. And this one can be moving down as well. So be square root x to the 5th power. So the final answer should look like this and look like this.
Wait.
Wait, what?
Bro,
Oh, because,
wait. Ain't no way.
Oh.
Because you should not have a negative exponent as your final answer, right?
Yeah.
So you move downstairs again after you finish taking derivative.
Yo.
Can I just leave it the other way? Because that's way easier.
Yeah, but it's hard to evaluate a number if you do it that way. Let's just say, what if x is equal to,
Okay.
I don't know, 32 or something like that. So it's much easier to plug in on the denominator.
I get your drift, Mr. Yen.
Okay.
Very good.
I get your vibe.
I think I actually want to see that. Why did it happen? She didn't.
Okay, so let's just say y is equal to, I don't know, y equal to 1 / square root x, right? I say, hey, can you find equation of tangent line at x equal to 4? At x equal to 4, can you find me equation tangent line x equal to 4? Now, remember, you don't need a definition of derivative anymore. It's at tomorrow's quiz. So tomorrow's quiz, you're gonna have to show me definition of derivative. You cannot use the power rule, just because if you show me without power, I want to see your algebra. But today, you can use definition of derivative. You can use power rule now. So you can find equation tangent line at x equal to 4. And even normal line. Do you guys remember what's normal line? What is a normal line? Yeah.
Like slope intercept?
What's normal?
Yeah, it's like the slope intercept.
Or normal line.
Oh, it's like the.
It's
the
orthogonal.
Perpendicular, yes.
Not that.
It's it's all normal perpendicular.
See, they're trying to rob you.
What happened, Deborah?
She
What?
was making fun of my
No, I'm not. I'm
Yeah, anyway.
I cannot say derivative. The derivative.
derivative.
It's differential.
I think you're with it.
Differential.
I can't spell it. I was like trying
Yeah,
to.
I was looking up there and I couldn't even like say what you would have.
The reason why I don't know how to spell that, that's just write down DIFF.
I feel like you
You gotta do it in essay.
every time I feel like you like were scribbling like in the middle section. I was like,
Yeah,
crap, because I don't know how to spell it, so I was trying to like fact check myself.
Is differentiable the same thing as derivative?
Differentiable means you can take a derivative
Okay.
and you can plug in a value. And derivative is the action
Okay.
of taking derivative.
To the right. Also.
So how do I find the equation tangent line or normal line at x equal to 4? Remember, we can use the power rule now. We don't want to do that long definition things, right? So first of all, I need to get y value.
Oh, it's 1/2.
Y value is 1/2. Good. So f of 4 is equal to 1 over square root of 4. That's equal to 1 over 2. Right? Now I have to take a derivative. So what is, so let's just say this is f of x. F of x here. And I can take a derivative of this. So it'll be x to the negative 1/2. And f prime of x is going to be what? Negative 1/2 x to the what?
Negative 3 over 2.
3 over 2. Now you got to change it to the bottom, right? The reason why you need to change the bottom is easier for you to evaluate this. So be negative 1. So I'm gonna evaluate this. So be f prime of 4 is equal to negative 1 over 2 square root of 4 to the third. Now, do I do 4 to the third first or do I do square root first?
Square root first.
Square root first. Good. So be negative 1 over 2 times 2 to the third. So be negative 1 over 32. No, the 16, sorry. Negative 1 over 16. So it's going to be y minus half is equal to negative 1 over 16 times x minus what?
4.
4. Now, if it's normal line, it's going to be what? Y minus 1/2 is equal to 16x minus 4. This is normal line. This is a tangent line.
I know I answered it, but why do you do square root first and not the cube?
So it's easier to work with brackets. So we have a pretty big number.
Oh.
Because you got 4 to the cube is 64. It's way bigger than it necessary. What if 4 to the 5 power, right? 4 to the 5 power, I don't even know.
That's so bad. That's so bad.
Strike out number 2.
So do roots first. Root first. It will help you. Root first.
I know you just said this, but where did the 16 come from? Like, I'm confused.
It's normal line, so if it's perpendicular, you would take the opposite reciprocal of it.
Oh my god, wait!
Right?
I forgot
Right?
that was a
Okay.
thing.
Yeah. Okay.
Oh my god. That's that one red. Oh my god.
Am I going too fast, guys?
Nah, you're chilling down.
Okay, so you gotta be careful. Be careful with the constant. What if you have a constant in the front? So let's just say if it's called constant multiple rule. Constant multiple rule. If I have d to the dx of c of f of x, I am gonna take the c that's in the front, and I'm gonna say c d to the dx of f of x, and then I'll take a derivative after that. So it'll be what?
What do you mean?
C f prime of x.
So just as a scalar on your.
Yeah, it's kind of scalar. Yes. How do you know that word? That's physics.
That is physics.
That's smart.
Oh, that word.
Deborah sounds very smart right there.
I do sound very smart.
Scalar.
Enjoy it now. 'cause
I was like,
Always sounds
Oh my
fun.
I was like, whoa,
I'm using way too
scalar.
many brain cells on this one moment.
Okay,
So there's gonna be none left for tomorrow.
I'm not coming tomorrow anyway.
but you also have to pay attention to the parentheses.
Wait, but we have a quiz.
Go take that.
If I d to the dx here, let's just say I have 2 over 3 x to the 5th like this. Can I just take 2 over 3 outside?
Yeah, wouldn't that make it 1 over?
And if I take a d to the dx, here it's going to be x to the negative 5 over 2. Why is it negative 5 over 2? Because it's denominator. If I move the numerator, it's going to be negative 5 over 2. And let's take a derivative of this, 2, 3. And that's negative 5 over 2. X to the negative 7 over 2. So this one's going to be negative 5 over 3. X to the 7 over 2.
Wait.
Negative 5 over 3. X to the 7. I just take a constant in the front, just ignore them for a little bit, and take out of down the power. And 2 and 2 cancel out, it's going to be negative 5 over 3. X to the negative 7 over 3.
Oh, let me say.
It's coming back, it's coming back.
You know what, Kelly?
You know, let's alternate multiple. Let's rock it.
If y'all made me do that, I would literally kill you.
Are we okay here?
No.
No?
What happened from the second sentence?
Shh. I'll take out 2 over 3 in the front. And this move to the top so I can take a derivative. And how do I move to the top? This one's x to the 5 over 2, right? If I move to the top, it's going to be x to the negative 5 over 2. Does that make sense?
Yeah.
But then how do you get from that to the
I take a derivative, take this in the front. So this one is going to be here. And then x to the subtract 1. So it'll be negative 5 over 2 subtract 1 is going to be negative 7 over 2.
It's still big brain.
Okay, sorry. That tripped me out a little bit. It makes sense now though.
All right, so does it make sense?
Yeah, it makes sense now.
Okay. Now what we're gonna do is we're gonna give you 4 situations, but I'm gonna put in parentheses. So you have to understand, parentheses is like a typing. It's like parentheses is like space bars. Like imagine you typing without space bars. That's what parentheses is. Parentheses is like a space bar in when you're writing an essay. So you cannot write an essay without a space bar. That's like the most important key there. Okay, so parentheses is gonna tell you where order operation is. I want you to take a 5 different derivative in this case. I'm gonna say y is equal to 5 over 2x to the cube. I want you to take a derivative of this. I want you to take a derivative of 5 over 2x to the cube. There's a small difference there. And there's also a difference on this one.
Oh, because you would try to cube to 2
And there's a difference on this one. So I want you to take a derivative on all of them. So first thing, I will rewrite this though. Rewrite something that in algebra will be able to take a derivative first. So if you rewrite, then you differentiate. You don't want to differentiate as s. You want to rewrite them to where a expression that you can take a derivative. So how would I rewrite the first one, where you can take a derivative? How you rewrite the second one, where you can take derivative? Third one and fourth one. Get off here at what time?
She has it. She has it. Okay, but other than that, did you get the same? Mhm.
I'm gonna just start working on this.
We love you too, Tony. Same thing, same difference.
I haven't taken derivative yet. And if I take a derivative, I'm gonna put a y prime here. So it'll be negative 15 over 2, x to the negative 4, or negative 15 over 2, x to the 4. Did you guys get it right? Is that okay? Because it's a, remember in the algebra 1 says it preferred to be positive exponent, so I put it underneath.
I'm confused on the last, but like, so.
Oh wait, that's the third power, not the second. That's, no, I had it right.
Negative 2 powers. When you subtract the
It's weird, bad handwriting strikes again.
His bad handwriting, yeah.
Shut up.
Can I, wait. Can you at least look at this and tell me what this is like? Like if it was to the second. Me and your handwriting, that's my arch nemesis in class.
Yeah, that's fine.
Thank you.
Oh, yes.
I'm about to do it like that. I think that's
Okay, 7 times 9, quick math.
No.
Quick
What?
math.
It's
16
like
over.
two.
16. Wait, what? 63. 63. Yeah.
That's where you write as. What is 2x to the third?
Yeah.
8x to the cube, because the third power is applied to 2 and 8, right? Can I rewrite that as equal to 5 over 8x to the negative 3 to the numerator before I take a derivative? Y prime is equal to negative 15 over 8x to the negative 4, or negative 15 over 8x to the 4th.
And we just forgot how to take a derivative.
Remember, today I don't want to use the definition of derivative. This is gonna be all day if you do this. Trust me. Power rule. Tomorrow, you're gonna have to use because I says use definition of derivative. Use definition alternative derivative.
Wait, for the last one. Okay.
Am I going too fast? Al, am I doing okay?
No, you're doing fine. I just.
Yeah, this is
I
very
get
good
negative.
because of the negative.
I just.
Okay.
That's nice.
We could probably go back to algebra 1D for me. That's what I'm saying, because
What time we get off here?
9:10.
we have 11 minutes.
All right, so let's do y. Rewrite this. How do I rewrite this?
Ooh, I
7/3 d over dx.
7x squared.
X squared. Good. Then let's take a derivative. This is kind of easy. So 7/3 times 2, right?
Yeah.
14/3.
X to the 1. So it'll be 14/3x. And I don't need to change because that's positive exponent.
I like that one.
So we
This was the last thing I got it.
Yeah, I hope
That makes so much.
The last one.
How do we do it?
This is how we
Well, that's going to be 7 to the 3 to the negative 2, right? X to the negative 2, right? Can I move to the top?
Yes.
So 7 times 3 square. X to the square. So it'll be 63x to the square, right? And if you take a derivative, that's going to be 126x.
Whoa. Wait.
Did you multiply by 2?
Yeah. Wait.
Yeah.
Yeah.
Oh.
It's like so.
That's what I forgot. I was like,
Well, my brain grows the calculus every day.
I know.
It's like
okay, so you have 63x squared, right? We still gotta take the derivative.
Oh.
So you move the
Do you see that? I didn't write down derivative. I write down derivative on this side. I say y prime. So that means I have an action of take a derivative. So that way it's how I keep a track of things. So you gotta learn how to keep a track your stuff. And that's gonna be, that's that.
What's the homework history?
Not yet, we're not done yet.
Ooh.
I'm excited for the moment.
You mean me or Deborah?
The room, the atmosphere.
Okay, so let's just say if I take a derivative of some function plus another function. In that, and some people think that just distributive power, but it's kind of true. It looks like distribution. If I take a d to the dx of f of x minus g of x, again, you probably can safely assume that's f prime of x minus g prime of x. So just take a derivative of each things. They are kind of like just a very easy just very easy rules. So what if I have f of x equal to 3x squared plus 2x minus square root x? How do I take a derivative of this?
Would you have to take a derivative of each one?
Yeah, because they're adding and subtracting. So what's derivative of 3x squared? What's derivative of 2x? What's derivative of x to the...
Yeah. 2. No, 2 over x. No, 2. Do 0. We did. Nothing.
No,
We do that.
no.
One minus 1 is 0. X is 0 powers.
It was 1, so it's 2. 2, yeah, that's what I said. Minus 1/2 x times negative 3 over 2. Negative 1/2 x is negative 3. Yeah.
I don't think that last part is right.
But it has a negative side in front. Wait.
Yeah, negative
Yeah, the same thing.
No, it's
It's
1
1/2.
over. No,
It's 1/2 x to
It's 1
negative
over
1/2.
1 over. No, because it's
The negative 1/2.
no, because it's 1 over
It's 1/2
radical
x
radical
to
x
negative 1/2.
because you can't lose it.
Oh, you have to do the whole. Yeah.
Yeah, it's 6x plus 2 minus 1 over radical
Okay.
x.
Mia, what's the derivative of 3x squared? Good. What's the derivative of 2x? What's the derivative of 2x?
It's just 2.
It's 2. Think about what is slope of 2x? Just 2, right? Slope of 2x, like y equal to 2x. That's just 2, right? Or think about that 1 go down. It's going to be 1 times 2, x to the 0. X to the 0 is 1, so it'd be 2. Does that make sense? And this one is 3x squared plus 2x minus x to 1/2. So that's going to be minus 1/2 x to the negative 1/2. So it'd be 6x plus 2 minus 1 over 2 square root of x.
Wait.
Minus one.
Wait.
Wait, isn't it
Yeah.
3?
Okay. Sorry. I'm a little pissed off.
Is that a 1 or is that like half of that? Wait.
No,
I think it-
no, it's a 6. It's 6x plus 6.
Oh wait, that's
Yeah,
yeah.
Oh, it's
We need different-
I have ladies.
You're like my like translator.
One time?
That's so stupid.
You want some right now?
It makes sense now.
Are we okay here?
Now I'm okay.
1.
We're good.
Okay.
Oh,
This one's going to be quite hard.
I like adversity.
I don't like adversity. I want my life to be easy.
Agreed.
Very base. We were not this is disgusting.
What's derivative of this?
Gonna be.
Well, you still have to take the derivative of each part.
I don't think so. You have to break.
You had to what?
You have to break the 2
X over 1
squared, 2x squared minus 1 minus x to the negative 1 to the.
I won't break it that way.
Uh,
But you're right about breaking it apart.
So we have to break it to numerator and denominator.
4.
Yeah, so it'd be 2x squared over square root of x, right? Minus 1 over square root of x, right? Does that make sense? You break it apart because bottom's one term. We talk about bottom's one term.
That's big break.
That's going to be 2x to the 3 over 2 minus x to the negative 1/2. Why is negative 1/2? Because the denominator make it there. So it'd be 2 times 3 over 2 x to the 1/2 minus
You could tell.
plus 1/2 x to the negative 3 over 2.
How do we get to second step?
That's squared over root x. Oh, he converted the negative 1/2 from the bottom. He turned the square root to negative 1/2. Yeah. Yeah. He looks so adorable. He's worried about being.
That's actually our bro.
So this step still f of x, right? And the next step is where the f prime x happen. Not after you split its derivative. It's after you split, simplify, and then take a derivative. No.
You said curling. Accident.
You have to just say that?
Yeah, multiple times today.
Oh, that's not bad.
Can't use the power of the.
You have to use the definition of the derivative. You have to know the alternative. You have to know horizontal text.
Damn. I'm just asking.
After love, what?
People just don't listen, I swear.
Bro, it's too early.
Yeah, it's early, bro.
It's way too
It's not
early.
here, bro.
You have to go back to sleep.
It is 9:09.
Why did you have this profile picture?
Why does it make sense?
How many do I have left? I have 3 more days at Modo. Alright.
See, I'm rarely tricked in front of like a public setting. At home, I'm like a sailor, you know?
It's very salt and show you tomorrow.
Wait, what?
Did you have people